we're going to try and investigate timers a little bit more in depthly and really get down to the core of what the T on and the T off do for us in ladder logic. Now I'm just going to plug my YouTube page a wee bit here because, you know, look, there's hundreds of videos on this YouTube page, especially in relation to ladder logic, both from Mitsubishi, Siemens and CODESYS. Now, if you're just focusing on the ladder logic itself and not the independent software, you really want to be watching all these videos and seeing how they interlink, because a lot of the stuff I cover in Siemens is very, very relevant to what I cover in CODESYS. And you know, I don't repeat a video that I've done for Siemens, I don't necessarily repeat it in CODESYS. So you're really forgetting the full kind of range and understanding all the code and all the ladder logic you need to be looking across, because at the end of the day, it's ladder logic and there's only slight differences between the software. A lot of the ideas are very, very similar. So I do cover a couple of timer videos in Siemens and in CODESYS, but I'm just going to develop on a little bit more now with them. So hop into our CODESYS, and what we're going to do is we're going to start off with looking at our ladder elements and bringing in a normally open contact. Okay, I'll drop this in and we'll call it a start button, and we'll do our usual declaring normally open, so start false, percentage I x 0.0. Lovely. And we eventually want this to turn on an output. Let's call this an LED. Again, if you want to be complete, false, percentage q x 0.0. Sorry, percentage. There we go. So we've an input and we've an output. Alright, now we want to look at a timer. So we're going to bring in a T on. So we drop in our T on, usually give it a name. T on, exactly what I had there. T on 0 is completely fine. Again, just accept the standard numbers for it. We want to say how much it's going to count up to. Well, we'll give it a 10-second timer. So we usually do T hashtag 10 and then S. And now CODESYS, one of the slight differences between CODESYS and Siemens, you'll see their timers are, you know, set up the exact same way, except we just have to give a value in here because the compiler doesn't like an empty one in CODESYS. So I just put in T0 because it's T on 0, and I tend to just again space out my timer elements and my inputs and outputs, so it puts them in automatically. Don't need to worry too much about them. So I've gone through in videos, you know, what the T on means and what all these different connections mean, but essentially a T on means that an output turns on after delay. So a timer on delay means output turns on after delay. So what we'd expect to see here is we push the start button, time's up, and then it comes on. So push the start button, we have a delay, and then the LED turns on. Alright, so let's just look at that in a little bit more detail as well. So I'm going to link this input, make it a tap button, link it to the variable start button that I have here, and then my output, link that just to the LED. Okay, easy peasy. And what I'm going to do is I'm going to bring my visualization down a little bit just so we can actually see what's happening. So we're going to do a simulation, so we're into simulation mode, and we're going to log in and download that into the virtual PLC. So you'll see there's nothing too exciting happening, but if I push the start button, sorry I haven't pressed play, there we go. If I push the start button, the timer starts to count. Okay, start to count up. Now remember my finger's still on this push button. See if I keep it pushed, right? And then if I remove my finger, see the way the timer drops? So I've got to keep my finger pushed on this push button in order to time up right up till 10 seconds. Once it gets 10 seconds, the LED comes on, but I'm still keeping my finger on this push button to keep it on, and then when I take it off, it turns off. So I'm pushing the start button, and then if I remove it, the counter comes down, right? Starts falling down. So that is a really interesting property in the sense that whatever's powering the timer needs to be latched on. So maybe we've used a memory bit or something to use the memory bit or latched input that will get that built up and then turn on the LED. And we've looked at some of them in other videos, but really I just want to focus on what's happening in here in the timer. So what's happening is it's counting straight away as I push the push button. Okay. Now let's log out of that for a minute. Alright, so let's just put that back in. Come into our code, log out, and let's take another button. Alright, so oops. So move down here. Make another input. We'll just call this a sensor. Okay. And again, I'm going to have another LED. Pop that down. LED 1 and our output. So bring in a new network. Pop that in there. Into our ladder elements. Contact. Call this sensor. We have our output, which is going to be our LED. And then we're going to bring in a T off. Okay, again, yeah, T off 0. Okay, and this is T0, but it's, call it off. So we're just putting in the standard value for that there. Again, this is going to, well, we'll make it, let's say, a 5-second timer this time. Now get into our visualization, copy and paste this down, except we're going to use some different. So instead of this, going to be called sensor, spell it right. It's going to be linked to that, it's still going to be a tap button. I'll link it to our sensor. We'll change the color of this to yellow, and we'll link it to LED 1. Right, now we'll give it, well, we're okay. Now let's look at what happens in our simulations. Okay, so let me see if I can maneuver this a little bit better, just so I can see exactly everything. Right. So log in, go to downloads, yep. In run mode, perfect. I'll bring this down again. Right, so again, push our start button, start counting straight away, and eventually when we hold this down, or holding down the start button, gets to 10, LED should have came on. Let me just double check something really quick. Let's see, just put this back into position. This should be boom, boom, boom. LED 1. Yes, I see my mistake. I didn't change that to LED 1. We had an output reference twice on the right hand side, which we can't do. No problem, so log back in. Put it into play mode, run mode for PLC. Get our visualization out. And let's look at what we have. Right, so same again. Press start button, we're holding it down for 10 seconds. So my finger's on the start button, gets up to 10 seconds, and the LED will come on. Perfect. Now watch this T off. Press the sensor, the LED comes on, but look at the count. Hasn't started counting yet. With a T off, it only starts counting when I remove my finger from the input, and then it will count down from 5, and then it will turn off. So there's a distinct difference there between those two. Now, if I just, tap it, kind of works the way we would initially think it would work. We just, tap the button, counts down for 5 seconds, great. Now, if we tap this, we haven't energized it enough to, get it up to 10, and then it gives the output. So you can see latching can be very important here, whereas if it was latching here, we'd actually cause a couple of problems because the LED would just stay on and it would never count down, because it only starts counting when I remove my finger from the output, and then it starts counting down. So there's slight differences between the T on and T off. The T on counts from a rising edge, so as we initiate the input, it starts counting, whereas the T off only starts counting when we release, so a falling edge from the input, and then it starts counting. So understand that in a bit more detail really, adds the value to your coding, and you can create, much more powerful things because you can use these in very sophisticated ways. Now, we've also covered in videos that essentially a T on, we can arrange it in a particular way to become a T off anyway. I tend not to use T offs a huge amount just for this reason, that it always is on the falling edge, which may not be ideal, because if a button gets stuck in real life, or if a sensor is left on, or triggered on and not come off, it can be a wee bit awkward. But there definitely is a place for them, and I definitely do use them. But T on, it can be, at the start can be quite easy just to use and just to follow that and understand the T on, because essentially we can create a T on to make a T off like scenario using latching and memory bits that I've covered in that in a different video. But I just really wanted to get in that idea of what the difference between T on and T off, how the T on counts on a rising edge, so when you push the push button initially, it'll start counting, and how you need to keep that latched on and to power it right up in order to turn on the output. And the T off, it only counts on the falling edge, so when you remove your finger from the input or from the sensor, whatever it is, then it will be able to start counting down. So just a bit more information to let you think over.